We're going to start by just looking at some patterns, okay? 2 to the 4th power. What is 2 to the 4th power? What are those two numbers? Why's one small and one big? What do you know about that? One's an exponent. One's an exponent. Which one's an exponent? The little one's an exponent. The 4 in this case, right?
Everyone knows what 2 to the 4th power is.
What is it?
16.
That's right. Everybody knows that.
Sorry, I just couldn't calculate it in my mind.
We've got one of those numbers that's an exponent.
I know what 10 to the 7th power is.
Good. I'm going to ask that question in just a few minutes.
It's 10 million.
Okay. One of those is an exponent, also called a power. The other number has a name called base. Okay? The base in this problem is 2, and the exponent is 4, and altogether it's a power. Okay? Power is what you're doing instead of adding, subtracting, multiplying, or dividing. But really, this is just a shortcut way to write a multiplication problem. Right? What multiplication problem does this represent? Okay. And what answer did you tell me this was? 16. Okay. Okay. What about that one? Tell me what you know about that one. What's the exponent? 3. What's the base? 2. Do you know the value? Okay. What about this one? Okay. What about this one? 2. Anybody got questions on that? All right, let's move over. Let's do another list. 5 to the 4. What's that?
It's 625.
625. What about 5 to the 3rd?
You're welcome.
Okay, do y'all agree it's 125? 5 squared? 5 to the 1? 5. Okay. Let's talk about one more list. 10 to the 4th. Somebody said 4, and they were probably about to say it's going to have 4 zeros, right? It's a 1 and 4 zeros. That's what you learned. Which makes the number become 10,000. What about 10 to the 3rd? 10 squared. 10 to the 1st. Okay. I want you to look at these lists, and I want you to look at their values as you go down the list. So let's focus on the first list. Describe to me what happens as you move from 16 to 8 to 4 to 2. Dividing by 2. That's what's happening every single time. So as your powers decrease by 1, your value divided by 2. What about the list of 625, 125, 25, and 5? They're divided by 5. And what about the list of 10,000, 1,110? They're divided by 10. Okay. So if I were to continue the pattern with 2 to the 0, now what did you tell me, Katie? You said divide by 2, right? Divide by 2, divide by 2, divide by 2. What's 2 divided by 2? Katie? 1. Well, what would happen if I went one step further? Let's just continue. What's that? It's 1 divided by 2, right? I mean, isn't that what we've been doing? 1 divided by 2? How do you write 1 divided by 2? What if you went one step further? It's a half divided by 2. If you have half an apple and you divide it among 2 people, what does each person get? 1/4. 1/2 divided by 2 is 1/4. What about this one? What's going to happen when you take that 1/4 and divide it by 2? Okay. Well, let's talk about the next list. You told me that you were doing this as we went down. Is that correct? Yes? So what would I get if I did 5 to the 0? What's 5 divided by 5? What about 5 to the first power? You got to take 1 and divide it by 5, and what do you have when you do that? Okay. Yeah, -1 is what's happening. 5 to the -2. 5 to the -3. 1/125. So let me ask this question. When the exponents are negative, is your answer negative? No. Let me ask it one more time. When the exponent is negative, does it make your answer negative? No, it does not. Okay? No, it's not 1/8. It's 1/125. It's 1/125. It's like taking a pizza, cutting it into 125 little squares, and you get one of them. 1/8 would be taking a pizza, cutting it into 8 squares, you get one of those. A lot bigger pizza, correct? That's the decimal equivalent. Hit math enter. 1/8 is 0.125, but it's not 1/125. There's a difference between them. Okay, do the 10. What did you tell me we were doing as we went down the tens list? Dividing by 10. So what's 10 to the 0 going to end up being? What about 10 to the -1? 1/10. What about 10 to the -2? What about 10 to the -3? Okay. Now, what if I were to ask you about, I don't know, 4 to the -3rd power? We've done all this. You've used all these patterns. What if I threw something at you that said 4 to the -3rd power? What? And I removed all the technology from the room. Come on, no more words. Come on, no more words. You have to divide by 4 3 times. Let's look at these lists. 2 to the 3rd is 8, right? What's 2 to the -3rd? 1/8. Connection? These are the two I'm focusing on. All right. Five to the second is 5 to the -2 is connection.
Is it the same connection for all of them?
Yeah. So whatever this is really what? 1/that value.
That would make it
1/64.
And these decimals get smaller and smaller.
Yes. Okay. Let's suppose I gave you this problem. -1.23 to the 0 power. What do y'all think that is?
I think
1.
always
1. Any number other than 0 to the 0 power is 1. And any negative exponent requires you to move it to the other part of the fraction. That's what we're doing here, okay? That's what we did with that first one. So what if I have 3 to the -4th power? The first thing I want you to see when you look at that is that it's really 1 over what, y'all? 3 to the 4th. Have we looked at enough of this that you see it makes a connection every time? Okay. Now calculate 3 to the 4th and tell me what you get. Okay. So if I had 3 to the negative x power, you could write it as what?
Just X,
1 over 3 to the x. I can't give an answer because I don't know what x is, right? What if I had x to the negative 5th power? What could I do with that one?
One over X.
1 over x to the 5th. And if I knew the value of x, I could go one step further. Okay?
Wait, so when you X, okay, so when X is the base, the exponent's gonna be positive, that kind of brings all it down.
Okay. Here are the rules. Here are the rules. We've looked at the exploration. Let's talk about the rules. If I give you this problem, there's a rule in mathematics that says do not leave a negative exponent in a problem. Okay? You have to transition it, translate it, fix it, whatever you want to call it. You can't leave a negative exponent in a problem. So tell me how to fix the first one. 7 to the negative 1. What is that equal to? What can you write it as and not use a negative exponent? 1 over 7 to the first. So you fix the part about the rule that says you cannot have a negative exponent. Check. I've taken care of that. I've got 1 over 7 to the first, which I know is really what? 1 over 7.
Okay, now I can.
Okay, what about this one? What's your first thing you're going to do to fix that?
1 over 8.
So 1 over 64. What about this one?
1/14.
Okay.
And
Suppose I have negative 4 to the negative 3rd power. Fix the negative exponent. It's okay for numbers to be negative, but not exponents. So fix the negative exponent. How do you do that?
1 over negative.
Okay. So I fixed the part about can't have a negative exponent. So I've got 1 over negative 4 to the 3rd. Anybody got a question about that? Comment? Now, what do you do when you have negative 4 raised to the 3rd power? What does that really mean? Negative 4 times negative 4 times negative 4. Which is what kind of number? Negative 64. Okay? Just because the exponent is negative doesn't cause the answer to be negative. What causes the answer to be negative is when you've got a negative number raised to an odd exponent, right? If that had been negative 4 times negative 4 times negative 4 times negative 4, my answer would have been positive. So I don't want you to think the negative in the answer comes from the exponent. It doesn't. The negative exponent causes you to actually move that item across the fraction mark. Now, with all that being said, let's look at this example. 4yx to the negative 3. Take what you've learned about these numbers, we're going to apply them to these variables, okay? If an item has a negative exponent, it's violating the mathematical code of ethics. And to fix that, you must move that item to the other part of the fraction. Okay, we've been working on it all morning. We've been moving numbers to the bottom and getting their values, but now we got variables. So we're going to do the same thing with the variable, but I want to know what's that negative 3 attached to? The x. Is that negative 3 attached to the y? Attached to the 4? So the only part that moves is the part that's got that attached to it. So this is 4y over x cubed. Okay? Let's do another one of those.
Okay, let's
3ab to the negative 2. Which part of this has a negative exponent attached to it? The b. So it's the part that has to be moved. You follow me? Yes? Anybody got a question? Not yet? What happens if you have 1 over w to the negative 4th? This is the first time we've seen a variable with a negative exponent in the bottom. Now the rule says if it's got a negative exponent, you've got to move it to the other part of the fraction. So if it's in the top, we've been moving it to the bottom. That's all that they've shown us so far. Now it's in the bottom, so we got to move it to the top. So what is this going to be? W to the 4th. What if I have 1 over x to the negative 3? What's that? What if I have 17 over x y to the negative 2? What part of that has to be moved? The y. So what does this translate into? Okay? Why did I only move the y? What is the exponent on the x? 1. When you do not see an exponent, that means there's a 1. What's the exponent on the 17? 1. Get on the desktop. Everybody good? Okay. 3m squared t to the negative 2. Evaluate when m is 2 and t is negative 3. The first thing you do, you take care of any negative exponents. So tell me what do you think I need to do first on this problem?
Put all the numbers where it happens.
Put t squared in the bottom, okay? So when I rewrite this, it's going to say 3m squared over t squared. Why did I do that? Why did I do that? Leah, why did I have to put t squared in the bottom? Because it had that negative 2 exponent. Did I throw the whole exponent out the door? What did I do? Just took the negative off. Now, m has a value of what? 2. And t has a value of, okay. So now I can actually find the answer, right? What do you do first? Tom? Okay. Is it negative 9?
Oh, no.
Is it positive 9? Which one is it? How do you know?
It's positive 9 because you're multiplying the negative sign.
Okay. So what happens when I do that?
12 over 9.
Can I leave it like that, or do I need?
Simplify it.
Okay.
4 over 2.
Okay. Good job. Let's do this one. What do you think you should do first in this problem? Raiden? Put the end of the negative 3 in the bottom? So it's going to say W to the 0 over, when I put it in the bottom, does it say end of the negative 3? It says end of the what? End of the 3. Does anybody not know why we're doing that? Anybody need to ask him a question? What's the next step? Okay, so what do I put in here? 5 and negative 2. Okay, good. Oh, wait. He said, anybody want to help him out there? Anything to the 0 power is what, Adam? What, Gentry? 1. That's a hard rule to remember because we have been taught that if you multiply by 0, you get 0. But that's not what we're doing here. Okay? It's a little bit different. Now go ahead and help me finish the bottom. Multiply negative 2 3 times, and I come up with, what's negative 2 times negative 2? 4 times negative 2. One more time. Negative 8. Okay. Jesse? Good. What goes in here? See, we're going to use those. So on the top, what do I get? Good. Okay, on page 397, okay, I'm done. I'm going to stop there.